Where is chalk? Well, good morning, ladies and gentlemen. How are we? Now, I'm supposed to chase you people because when I give work, you don't want to do it. But being, let me call it the first time. Yes, ma'am.
I wanted some direction. This topic which we are going to start. Are we going to start or we just leave it?
Sinking and floating.
This is senior to
Anti-sinking and floating. I'm sure you are done with mechanical properties of matter.
Yes, we are going for lights.
It should be sinking and floating.
Sinking and floating.
You should check very well the syllabus.
The syllabus is showing light by calculators.
You know, it was from pressure to sinking and floating. Then
I'm done pressure a long time.
To sinking and floating, then mechanical properties of matter. But we're like, let them look at the known part such that by the time we take them to the complex part, because now this is not related to any other thing. So for me, I've done it, but you can take them to reflection on curved surfaces because it's part of what we're supposed to cover this time. Yes.
That's what I am. But we are going to have only 2 lessons. We are ending this very well.
It's okay. That one is back on the way. It's okay.
That's what I want.
All right. So I am saying that let us try to curb that tendency of not doing the work. That is a higher degree of being not serious. Am I clear? If it means doing the work, do the work. There is no other business that you have. My brother here, when you fail the work, my principle is I give work. My principle is I give work, I mark it. If you satisfy me, I comment, I date the comment, and I sign. Anybody I signed for? For that work? There are about 2-3 people. So it's not just a matter of you bringing and I cross, then you go back and say to when I cross, go back, do the work, and come back for marking until when I sign against that work handed in. Simple. And I'm sure you can. Because you have no any other business. The only business you have is to study, to crush all the numbers. Am I clear? So please try to adhere. If it means sleeping in books, you sleep in books. You guys push the desk in front. Because either something is taking your attention out there or the camera. Are we together? Then put it this way, literally this way. Again. Like that. Another thing I want to put across is these videos, I make them for you people, not for my own nani. Because number one, me, I studied physics. They are now 10, I started senior 6 2014. So they are now 10 years. I am a physicist. So whatever I am doing, I do it for your own benefit. My people who are day scholars, when you go back home, get a smartphone, go to YouTube, press in my name, they will bring you all those videos there. And you choose one. Now, like I'm supposed to teach today joining capacitors. I'm supposed to teach joining what? But the video is already uploaded. So you can compare what I'm going to teach you today, compare it with what is already on YouTube, and then see how best I have performed, either here or the other side. Are we together? So you choose one. You either choose to go by the one that is already uploaded, or you can go by the one that I have here. So I want to make this thing simpler. You will now have a right to either attend class or not to attend class, but you virtually attend class. Am I clear? Are we together? So you can choose either to be here or you decide to go and follow me on YouTube. I said you just put in my name, Israel Tebandeke. They will give you a simple brief of my background. Of course, you only need the academic background. You don't need the family background because nobody here is interested in my family background. Is there anybody? Not really. Eh? You are only interested in, is the person handling our physics a physicist? Simple. You are only interested in, did he study physics? Simple, you know? Knowing my status, whether maybe I am, maybe married or HIV positive or negative, is none of your business. What you basically need to know is, am I a physicist? Because in Uganda, it is very possible for an audience to be handled by not a professional person, but by a popular person. Are you getting the point? You might find that a person handling you is just popular, but not professional. That one is a very big problem in our country. Osanga omuntu nga celebrity nga mumanyifu naye nga si mumanyi oba mukitegeera. Do you distinguish between the two? Osobola okubeera nga oli mumanyifu naye nga tolina ky'omanyi. Kati ate bakuleese osomese ebyabamanyi. Okitegedde? So I am not popular. I am a professional physics teacher from Makerere University. So that one is basically what you need to know about the background. My daughter comes from behind there. Come and sit here. Hey, come and sit here. Unless you are long-sighted, but come and sit here. So, ladies and gentlemen, that is for your own benefit. I am trying to make sure that by the time I retire, at least I have a legacy behind. And one of you will be also a teacher. What does it mean? You sit around there, sit close to this man. So I am doing everything for the betterment of the next or the coming generation. Are we together? Yeah, so please embrace it. Go and give me views and likes. You follow me. You never know, I can earn something from there. Yeah. Are we together? Joining capacitors as a subheading. Now, capacitors can be joined. Capacitors can be joined. And when they are joined, what are the dynamics? What are the possible dynamics that can be looked at as principles of physics? What happens to when you join two capacitors but of different credentials? We know a capacitor can be charged to a given charge and then it attains a given PD, right? Now, when you combine the two, when you combine a capacitor 1 and a capacitor 2, what are the possible dynamics? Are we together? Are we together? When you combine a capacitor 1 with a capacitor 2, what if this is C1 and this is C2? What are the possible dynamics? What happens to the three things? 1, actually 4. What happens to the capacitance of the two? That is, of the combination. What happens to the charge on each after combining them? And 3, what happens to the PD across them? And then finally, what happens to the energy stored in the combination? Are we together? There are 4 basic questions that we're supposed to ask ourselves on when we join 2 of the capacitors. What happens? Now, literally, you are going to join the 2. Of course, there are a number of cases that we can take a look at, but we are going to emphasize on the case where one is charged to a greater charge than the other, or we can have a scenario where one is charged and another one is not what? Is not charged. Are we together? Then the remaining dynamics, you can also go and ask yourselves, what happens? My daughter, those are bad manners. Somebody should come, knock, ask for permission, and then talk to the individual. Are we together? Are we together, ladies and gentlemen? So the joining of the capacitors looks at, number 1, what will be the arrangement? Number 2, what will be the charge on each after the joining? Number 3, what will be the PD across? And the PD across is also going to be determined, or is going to determine, what arrangement shall the 2 display. Are we together? Are we together? You guys don't want to talk to me, right? So you can take note. Take note and say, when 2 capacitors are joined together, 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 semicolon. 1, charge flows until the PD across the capacitors is the same. Charge flows until the PD across the capacitors is the same. Charge flows until the PD across the capacitors is the same. Charge flows until the PD across the capacitors is the same. That is one fact. That is one what? One fact that we shall numerically apply. Fact number 2, the total charge on the circuit is conserved. The total charge on the circuit is conserved. When you join 2 capacitors, the total charge is conserved. Fact number 3, the capacitors are in parallel. The capacitors are in parallel. The capacitors are in parallel, i.e., now this fact is built again by the fact that we noted that if you combine the 2, charge is going to flow until when the PD across the 2 is the what? The same. And for parallel arrangement of the capacitors, the PD is the same. So you can conclude by writing the capacitance, or the effective capacitance of the capacitors in parallel after the IE. What is the capacitance or the effective capacitance of 2 capacitors in parallel? Pardon? Yeah. You can write that. Write that effective capacitance of capacitors in parallel. I've said write the formula for finding the effective capacitance after IE. I've said capacitors are in parallel. So what is the effective capacitance for capacitors in parallel? And in this case, when they are two, then write that. If you know a fact, it remains a fact, even if you sit on it. Now you want to sit on that truth, i.e. C1, C equals C1 plus C2. How many facts are those? There are how many? There are three. You are lying. Check your facts. Then the fourth fact, note it as an NB. Write NB. Now, fact number one, we have said that the charge is going to be, actually fact number two explains fact number one. Are we together? That the charge on a capacitor C1 plus the charge on the capacitor C2 is conserved. It gives us the total charge on the combination after joining them. Are we together? Then fact number, this one is combining fact one and fact two. Fact three is saying that now these capacitors form up a parallel network. Form up a what? A parallel network. Which network? The effective capacitance of a parallel network is C1 plus C2 equals C. That is fact number two or fact number three. Then fact number four, I said, what happens to the energy? Question, is the energy on the two, ladies and gentlemen, the same as the energy on the combination? No. So what happens? Is it that the one before joining them is greater than the one after, such that we shall have the energy loss? Or the one after is greater than the other one, such that we can have the energy gain? The one after is, you are lying. Yes, my daughter here. What do you think? You are thinking that because the other one is wrong. Eh? You know, in this world, you are either a man or a woman. So if they say, I am not a man, automatically you will say now you are a what? A woman. Eh? Because there are only two genders on earth. Eh? You have a mixed one. I don't know, I've never seen. I am now 30 plus years old. I've never seen an hermaphrodite. I've never seen one. You are there. You know me, I'm a scientist. I believe in one by seeing, two by experimenting. You know, an experiment is carried out using hands, isn't it? So my little girl has not thought that far, because if the energy before is not greater than the energy after, what is, eh? If the energy before is not greater than the energy after, then it is what? It is less. So there is no logic. Is it there? Because if I come here and introduce myself, I am Tevandeke Israel. I'm not a male. So I am what? Simple. There is no thinking there. Hermaphrodites, those are... Ideally, I don't want to deceive you. I don't believe in them. However, I do believe in thinking. You need to be critical thinkers. How many of you here knows how to play chess? Chess. It's one of the board games. It's a military game. Chess. People of this generation, you must know how to play chess. You only know draft. Draft, even villagers can play it. But chess, yesterday I was trying to liaise with a certain man, a superstar of chess in Uganda. And actually he teaches even his children how to play it. But he told me a technique that when playing chess, number one, if it is your turn to move a piece, if it's your turn to move a piece, you can, of course, you make one move, right? But that move you have to make, you choose it out of 20 moves that are available, which calls for critical thinking. And after you've made that move, you must actually also think of what will be the move of the opponent. Are we together? So you not only think for yourself, but you only think for the opponent. And the opponent is doing the same thing. That is how life, that is now how Uganda, it is no longer the survival of the fittest, but the survival of the smartest. I always tell my people in Kampala there that you are not a thief until when you are caught stealing or with evidence. But once you steal and you are not caught, you are just called a smart worker. Yeah, you're simply smart. But I'm not encouraging you to go on, because when they get you, they will crush your head. So I am saying that the energy before, let me call it EB, the energy before joining the capacitors is going to be the energy of each capacitor, right? Energy of a capacitor 1, which is a half C1 V1 what? Squared, plus the energy on capacitor 2, which is a half C2 V2 what? That is the energy of the individual capacitors before you join them. Are we together? Are we together, ladies and gentlemen? Now, after you join them, let me call it E subscript A. It's going to be a half CV what? Squared. Because when you join them, charge is going to flow until when the PD across them is what? Is the same. Right? And then they are going to form up a parallel arrangement whose capacitance is C1 plus C2. So the energy after is going to be a half into C is equivalent to what? C1 plus C2 times V what? V squared. Are we together? So in this case, we shall have what we call the energy what? The energy loss, which is the energy before minus energy what? Energy after. But still, this one does not mean that energy has been wasted. Does it? Does it mean that energy has been wasted? How does the principle of energy state?
Energy is when in conversion of energy, energy is neither created nor destroyed.
Energy can neither be created nor destroyed. Now, this energy that has been lost has only been converted from the form of electrical to probably heat. Because as charge is flowing into the connecting wires, you'll end up, when you feel them, they will heat up, right? So when they heat up, it means that the electrical energy has been converted to what? To heat. So the other fact 4 is NB. Write it as a note. Say there is loss of energy. There is loss of energy. There is loss of energy. There is loss of energy when capacitors are joined. There is loss of energy when capacitors are what? Are joined. There is loss of energy when capacitors are done what? Are joined. Full stop. This is because charge flows. This is because charge flows. This is because charge flows. This is because charge flows until the PD across the capacitor is the same. Until the PD across the capacitor is the same. Until the PD across the capacitor is the same. Until the PD across the capacitor is full stop. The flow of charge results. The flow of charge results. The flow of charge results in heating of the wire. The flow of charge results in heating of the wire. The flow of charge results in heating of the wire, and hence loss in energy. And hence loss in energy. And hence loss. Examples dictate example 1. Examples. Young girl, you must be lying. It is a 5 microfarad. And is then connected to uncharged. And is then connected to final. Part 3 is not there. So that is the scenario. Two capacitors were joined or were connected, with one having this capacitance 5 microfarads and the other one having 20 microfarads. These two are connected or are joined, and the dynamics we've talked about above took place. The charge on the other one flew across until when the two had the same PD. Now we are supposed to find number one. Number one is, what are we supposed to find first? The final PD across the two. Now, the final PD across each. Of course, we said that when charge flows across the joining, time comes when the PD is the same. So that one is going to be achieved from the fact that charge is done what? Charge is conserved. So conserving charge, of course, solution. Conserving charge, the charge on each capacitor. So we shall have Q1 plus Q2 equals the total charge when you join the two. But charge Q1 from capacitance of a capacitor being the ratio of the charge on either plates divided by the PD across the ends, making charge the subject of the formula, we shall have charge equals capacitance times PD. Is it right? So from Q equals CV, students can convince themselves whether it is true. Bring my duster. Fix it inside here. So that means C1, V1, for the case of charge Q1, plus C2, V2 equals CV, right? This CV is for the combination. These ones are for each individual capacitor, right? But in the question, they said that one of the capacitors is uncharged. What does that mean, therefore? If a capacitor is uncharged, what does it mean? It means what? Please speak louder. It means its speed is zero, the fact that the charge is zero. So this one will go to zero. So we shall have what is C1? Okay, C1 V1 will equal to, now this C is the effective capacitance, will equal to C1 plus C2 what? Plus C2V. Are we together? Are we together? So we can make now the substitutions. What is C1? 5 exponent times what is V1? 40 equals what is C1 plus what is C2. But these two are exponent what? Times what? Times V, what we are looking for. So I want you to convince yourselves that this can cancel with that mathematically. Then 5 divide 25, what do you get? Yeah? 5 divide 25, what do you get? Then this 5 divide 40. Convince yourselves that V equals 8 volts. Convince yourselves very shortly, in the shortest time possible, whether it is true. If not, you make the alarm. Put it here. We do write on the wood. Sit properly. Keep thinking. Don't allow sleep to. That's what I'm saying. You try and see whether you get what. If you follow, which step? This one here. This one. You don't understand the second step. But did you understand the first one? Did you understand the first one? Eh? What did I do here on the second one? What did I do from the first to the second one? That is one thing. But I am asking because he's saying he has understood the step one where I've conserved charge. But he's not understanding the step two where I have CVs. What we are doing here, I think, is is substituting for Q. The physics stopped here. The remaining work is mathematics. Where we defined C as Q over V. Do you remember this? Make Q the subject of the formula. What do you get? Q equals CV. So substitute Q1 is having capacitance C1 and it was initially charged to a V, which is V1. Even C2 had a capacitance C2 and it's V2. But for this one, it was uncharged. That's why I'm cancelling it out because it is equivalent to 0. Then equals the combination. The combination will have a combined capacitance and then the PD across the two is going to be the same. But that combined capacitance is in a parallel form of arrangement. And we say that the effective capacitance for capacitors arranged in a parallel network is C1 plus C2. Am I clear? Then the remaining work is algebraic gymnastics. Roman 2. Roman 2, what are we supposed to find? The final charge on each. Again, we are going to come back here. Substituting for Q1, because even when you join them, they will not have the same charge. But according to their capacitances, they will acquire charges according to their capacitances. From Q equals CV, it will mean that Q is directly proportional to C. Meaning the one with a small capacitance, that is 5 micro, will take a smaller charge, gentlemen. Then another one with a big capacitance will take a bigger charge. So they will not have the same charge, but they will have the same P, the same PD. So in this case, Q1 is going to be C1V, because after joining them, they will have the same PD, but different capacitance. I mean, they will have the same PD, but different capacitances calling for different charges. So Q1 will be that. What is C1? 5 exponent, then times what is V? 8. What do you get there as Q1? Pardon? 4 exponent coulombs. Then Q2 is also C2, but what? V, because it is the same P, the same PD. So we shall have C2 is 20 exponent negative 6 times V, which is 8. So Q2 will be coulombs. Then Roman 3. Now Roman 3, can my audience try it there? First find energy before joining, add it to, get the energy after, and subtract the two. I have already done this, so again repeating it. I'm not seeing anybody responding, please. Let me see. So can we give her a chance to take us through?
Morning, class. Okay. Go to Roman 3. Go to Roman 3 and says that we calculate what the final or the energy loss. In the energy loss here, you calculate the energy before and the energy after, and then you subtract energy before and energy after. Here, energy before will be equal to a half CV, half C1, then V1 squared. I have a half C1, we have 5 microcoulombs, then times CV1, we have 40 and squared. So here when we cancel 2, I have a half times 5 exponent negative 6. What is 40 squared? That is 1600. then by 2 1, here by 2 is 8. Then compute this and give me the answer. 4 exponent -3 joules. This is energy before. Then energy after. This is calculated from after combining the two of the capacitors. Here we shall have a half C1 plus C2 and V squared. Here the V we shall use here, it is the PD across both capacitors. And here we have a half times C1 is 5 plus 20 into 8 squared. And this is a half times here we have exponent -6, then times 8 squared. And here it will be, you add 5 exponent -6 plus 20 exponent -6. 8 what? 8 exponent and this one. What? Different formula? I'm not getting.
Why have you noticed a half
C1 like here. But energy after it is after combining the two of the capacitors. So energy before it is one of the capacitors. Is it? So after computing this, what do you get? Okay, what is the answer? 8 exponent -4. Then here, getting the rows, energy rows shall get energy before minus energy after. Here we shall get 4 exponent then -3 minus 8 exponent -4. Then what is the answer? 3.2. 3.2 exponent -3 joules. So this is the answer.
Let us all appreciate the answer.
Thank you. Now, basically, she has done it absolutely well. But my daughter here, we are looking at the energies that were on the capacitors in two cases, before they were joined and after they were joined. Before they were joined, we are looking at each capacitor's energy. I mean, each one's energy. The capacitor C1, whose energy was a half C1 V1 squared, because it was charged by a 40 volt speed. You remember? Now the capacitor C2 is also going to have the energy, which is a half C2 V2 squared. But coincidentally, my daughter here has not talked about it. But coincidentally, she has a correct answer. Why? Because capacitor C2 was uncharged. So the charge on it is 0 and the PD across it is 0. Are we together? I told the senior 5 science 1 that a memory card, it does not take away its capacity, even if there is nothing. You get the point? The storage of my phone here does not take it away to be 128 GB, even if there is nothing. It remains with that what? Capacity. So capacitor C2, its capacitance is 20 microfarad, but it is holding nothing at the beginning. Before it was joined with C1, it had no charge, meaning there was no PD across the ends. Are we together? So the rest of the work, have you understood now? The rest of the work is algebraic as she has displayed it. Example 2. Example 2.
Collected across then disconnected and then the capacitor. Then disconnected and then the capacitor of 40 microfarad. Like capacitor of 40 microfarad is connected and lost because battery supply. Because battery supply. When it has a free time, then disconnected and then capacitor of 40 microfarad. And then it then disconnected and then the capacitor of what they do disconnected and then the capacitor of what microfarad having a PD of 100 volts, having a PD of 100 volts, calculate Roman 1, effective capacitance after doing Roman 1, effective capacitance after doing in Roman 2, the PD on each capacitor.
Then Roman 3.
Energy lost.
Then dictate number 3.
Again, number 3, a parallel plate. Parallel air plate. The parallel plate. Then you write air, high capacitor. It's that the potential difference of 10 volts. Of 10 volts. Then connected parallel. Then connected in parallel. And start capacitor. It is then connected in parallel. parallel with an uncharged capacitor of similar dimensions. With uncharged capacitor of similar dimensions, but having equivalent. What is with similar dimensions, but having equivalent as the electric medium. Having the other one as the electric medium. The potential difference of a combination volts to 15 volts. Calculate the electric constant of the equivalent. The conversion voltage